Hey guys, and welcome to the X299 VRM disaster update video. So I posted this video last week and it went quite wild on all the medias. I'm kind of happy that everybody picked it up, but it also went a little bit over the top in some directions, especially because some of the details I made in the video were not clear enough. So some of you or reviewers out there could not replicate my results. So for example, Tom Logan from OC3D posted a video where he reviewed the X299 Strix from Asus and he could not reproduce the results. And I was basically talking to him on Skype for hours now and trying to reproduce what he was doing, and he tried to reproduce what I was doing. In the end, it worked out today. After days, we finally figured out what the issue was, and he can now reproduce the power draw that I can produce in my results. So he will soon post an update. He will soon post an update video as well. I will link you to his channel. Check this. So when he posts the update video, make sure you also check his video. So in this video, I generally want to talk about how I am testing and what kind of settings you need to push Skylake X to the limit. And there are a lot of factors you have to take into account, especially when it comes to detecting throttling. That's really not that easy. So that's what I want to talk about in this video. The first thing I would want to clear up is the my PSU is faulty thing. So I read a lot of comments out there that saying all my testing was ruined because of a faulty PSU. And I can assure you that this is not the case. I tested all my results 3 times with 3 different PSUs. So I tested the Superflow PSU, I tested the Seasonic 1200 watt PSU, and I also used the Corsair PSU. And the VRM throttles every single time, no matter what PSU I use. So that's for sure not related to the PSU. So talking about the 8-pin problematic, it's not that bad. So if you only do moderate overclocking, you can use a board with an 8-pin, even though I would still recommend 8 plus 4-pin minimum, especially considering the fact that we will see the higher core count CPUs soon with 12 to 18 cores, and those CPUs should draw even more power. And considering that with 300 watt power draw from an 8-pin, we're already running really on the edge, I would recommend that you still go for an 8 plus 4 or 8 plus 8 mainboard if you really want to do serious overclocking. So let's start talking about the settings you need for testing X299 Skylake X, detecting VRM throttling issues and all this kind of stuff. So one of the most important features we have to use for this testing is TJ max offset. So TJ max, the junction temperature, is the maximum rated operating temperature for those CPUs, and usually those CPUs are set to 94 degrees Celsius at the limit. And there is a feature Intel implemented, it's called the TJ Max Offset, and with that feature you can set this up to 105 degrees Celsius, which is really fine. So you can be sure if you just do some stability testing, for example with Prime 95, you can use this feature without worrying about your CPU. So the thing is, if you run, let's say a i9 7900X, especially if the CPU is not deleted, you will easily hit the 94 degrees Celsius temperature limit without being able to pull enough current. So if you cannot delete your CPU at the moment, because my deleter is still not available, I know, you probably have to use the TJ Max offset to make sure that there's enough headroom in temperature testing. I saw somebody out there, a reviewer, who tested his CPU at 4.6 and 1.35 volt AVX without TJ Max offset, without deleting, and he said, oh yeah, my power consumption was really low, around 150 watt. Yeah, it was low because the CPU was throttling. So the issue is he could not even detect the throttling in CPU-Z, because sometimes CPU-Z is not fast enough to detect the throttling. So that's an issue. So let's go over to how to detect throttling. My advice is you have to keep 2 things in mind. You have to always check the system power consumption, ideally the VRM power consumption, if you can read it out with software. For example, Hardware Info is very good for this. And always keep track on core temp as well. Core temp has, for some reason, a higher refresh rate or something like this. So you can check the multiplier of your CPU in core temp. And this should always report the correct multiplier. So if your CPU is throttling temperature-wise, not the VRM, the CPU, it would go, for example, from 45. If you run 4500 megahertz, it would go from 45 to maybe 40 and then 33. And this kind of behavior is CPU throttling. If you have small steps going down, it's CPU throttling. It's not VRM throttling. If this goes down from 45 to 1.2 to 12, like 1.2 gigahertz, it's VRM throttling. And that's the thing you always have to keep in mind if you're testing those platforms. To even be able to run the highest power consumption with your CPU and therefore the highest performance and highest clocks, you also have to do some settings in every single BIOS, no matter which mainboard vendor. So for example, for ASUS, it's very important that you disable SVID, otherwise your CPU will throttle. And you have to run in DigiPlus VRM control, DigiPlus VRM in the menu in the BIOS. You have to change the CPU current capability to 140%. If you don't do that, that's what happened to Tom Logan from OC3D. The CPU will stay at a higher clocks. It will look like it's running perfectly fine. The CPU would still run 4.5 gigahertz and the load is fine, but it's not running at a full speed. If you would run a benchmark at that point, you could see that the score is actually really bad. Even though it looks like it's running perfectly fine, but for him changing from 100% current capability to 140, running the exact same settings increased another 100 watt load. And that just shows that it's very, very tricky to replicate all this, because often you have throttling even though you don't notice it. Then there's one specific thing I noticed testing the Gigabyte board. I call it VCC in throttling. Not sure if that's the correct terminology for it. So the thing is, I was running everything on auto except for increasing vCore and setting XMP profile, disabling the turbo and fixing the CPU multiplier to run 4.5 gigahertz. And then I noticed that under load, the power consumption was really fluctuating. So it went from like 260 watt down to 150 to 200 to 260. And that was really strange. Even though the CPU always stayed at the same clocks, VRM temperature was also good in that case. I was not really sure what's going on there. So somebody pointed me on the VCC in, and I noticed that the VCC in was only at 1.7 volt under load, and increasing it to 1.8, actually increasing it to 1.9, which then resulted in 1.8 under load. The load suddenly went with the exact same settings to 300 watt and it was stable. So for some reason, running auto on VCC in, the VCC in dropped too low under load and then caused some kind of throttling in the background. Yeah, that was something really weird, but that's something you also have to keep in mind. So always check power consumption of the CPU. Talking about the Gigabyte board, I also read something very interesting in the internet. So there was this guy from Silicon Lottery. He's a guy selling pre-tested CPUs over in the US. And he also detected some very weird throttling stuff running AVX 512. So he mentioned online that he has trouble finding a board that does not throttle under load, because he actually experienced the same as I did. And he also noticed that there are some very high performance fluctuations running AVX 512 on the Gigabyte board, which are somehow related to some kind of throttling that's going on in the background. So there's a lot of stuff we still have to dig into. I hope other reviewers also dig into this and maybe we can find it out together, because I'm really not sure what's going on with the AVX 512 issue, but that's just something I wanted to point on the site. Another thing I would like to talk about is temperature reading. So in my previous video, I did not have hardware info latest beta, so I was reading the VRM temperature kind of by placing a temperature sensor, a K-type probe, behind the back of the VRMs. I put a little bit of thermal grease there and put a tape over it so it would have a very good contact. Then I was reading basically out the back of the PCB under load. Now for this video, I'm referring to temperatures which I was reading out with hardware info, which is usually accessing some kind of sensor that is placed on the board. Now the thing is, so for ASUS mainboards and for the MSI mainboards, the limit of the VRM is set to 105 degrees Celsius. Now, a lot of you guys in the last video commented that MOSFETs can run much higher temperature, which is right. So most MOSFETs, the higher quality ones, can run up to 125 degrees Celsius without having really issues. I'm not saying that it's really cool to run 125 degrees, especially taking into account the lifespan. Still, a lot of you guys said, but the MOSFET temperature is fine. So the thing is, even if you read out the VRM temperature by software, you never really know what the real MOSFET temperature is, because usually the vendors place a temperature sensor near the VRM, which is then reading out the PCB temperature that is close to the MOSFET. So it really also depends on where the sensor is placed. So for ACES, for example, they have the VRM and they place it pretty much in the middle, which is the worst spot. It should be the highest temperature in the center. And then I think it was ASRock. They had their sensor placed fairly on the right side next to the VRM. So then obviously you get completely different temperature readings, and that also explains why you also have different TJ max values. So it could be that for ACES they set it to 105 because they know in the middle it's quite hot, and then another vendor could set it like on the edge and then have a higher temperature reading, but it still in the end could be the same MOSFET temperature. There's just something I want to point out, that the temperature you're reading out with hardware info is not the core temperature of the MOSFET. So let's talk a little bit about my testing procedure. So the thing is, personally, I'm always testing worst case scenario. Working at Caseking, and especially working at Caseking SI, we're always testing worst case scenarios. So the thing is, if we sell overclocked systems, pre-built systems, it could be that we ship it to the customer is checking his system, it's overclocked, and then he's like, oh, let's check if this system is really stable. And then he's doing, for example, a Prime 95 full custom run. And the full custom run is very, very intense because it's running through different FFT sizes, and then it's utilizing the CPU in different ways. And if he's doing that, we have to make sure that it's also passing the worst case scenario of Prime 95. And we had those cases in the past where people were running those kind of tests and they were like, hey, the system is not stable, so they would send it back. So that's the reason why we always test worst case scenario. And especially during testing, we do not only do Prime 95, we also run Vrm at the same time. So we have the maximum temperature inside the case. We can be sure that our cooling is very sufficient, because if it can run the worst case scenario Prime 95 together with Vrm, then you know the system will be fine forever. So that's why I'm always using Prime 95 with the worst case scenario. So talking about Prime 95, it really depends on how you configure Prime 95, also depending on which version you're using. So that's also one thing. I was talking to Tom from OC3D quite a lot, and he's using OCCT for testing, and I always use Prime 95 because I can run different versions. I can run 26.6 without AVX, can run 27.1 with AVX, can run 29.1 with AVX 512, and therefore configure the system perfectly, because you have the normal non-AVX status. Then you can run AVX with an AVX offset, you can run AVX 512 with an AVX 512 offset, and therefore you can configure your system perfectly. And even within Prime 95, there are options. So you can run a test with different FFT sizes, and depending on which FFT size you're running, the CPU power draw and the power consumption is a lot different. So on HardwareLux forums especially, a lot of people are running 1344K FFT size, which has been popular for years there. And I noticed that the power draw with 13344K FFT size is actually quite low if you compare it to other FFT sizes or even Cinebench. So here you can see a chart I made. I did a lot of testing with different Prime 95 statuses. So this is all Prime 95's 27.1 with AVX. And you can see I was running the Prime 95 1344K, and it resulted in about 310 watt power consumption under load. This is the total power consumption of the system. This is not only the VRM power consumption. So you have to deduct, let's say, another 100 watt to go just to the VRM power consumption or CPU power consumption. So let's take a look at Cinebench. So the funny part is that Cinebench R15 is running like 330, 340 watt. And this is even higher than running AVX Prime at 1344K. So it could be that somebody of you is testing his CPU with AVX Prime 95 1344K, which I also used in the past a lot with Skylake and Kaby Lake, because there it was fine, but for Skylake X it's different. So you're running Prime 95 1344K with your Skylake X, and it's fine for 2 hours, and then you fire up Cinebench and it crashes on the first run. So that's the reason, because it's completely different in utilization. And Cinebench was even heavier than running AVX Prime with high FFT sizes. Running OCCT, I could run 400 watt under load. But the thing is, with OCCT, the load behavior is a lot different to Prime 95. So you have a load, then it goes down, it goes back up, so you don't have full utilization all the time. And of course, if you also do VRM testing, the VRM cooler and the PCB, they can easily cool down in the cool down phase and go back up. So that influences the test also quite a lot. And I also noticed that the core utilization is also a lot different. So Prime 95 is always 100% load. It's running really tough. And OCCT for some reason is not fully utilizing always all cores. So the power consumption is also lower than what I had with Prime 95. So let's take a look at the Prime 95 small FFT sizes from 8K to 12K, 96K, and you can see I was running 500 watt power draw from the wall. So that's like 400, yeah, maybe 350 watt from the CPU. So that's really a lot. And that's what I used for testing the VRM, because this is the worst case scenario. Because obviously if we're testing systems internally, we have to make sure it's running in every scenario. No matter what kind of calculation, it has to work. And so you can see with a small FFT Prime 95, the power consumption is absolutely insane, but that's what I use for testing. That's what I have been using always for every single platform I've been testing in the previous years, and it was always fine until this point when the VRM cooler was not good enough. So after testing all this and after I gave all these infos I collected in the last days to Tom from OC3D, he finally also made it and he could replicate the results. He also hit a VRM temperature of 105 degrees Celsius on the X299A, which is the limit. It would throttle down at that point. The thing is, his CPU would also throttle at that point because it got too hot because it's not delidded. So he could kind of replicate it, not the true VRM throttling, but he really went to the limit, and I'm really happy that it finally worked out. I think he will post an update video soon. Already check out his channel, I linked it in the description, and make sure you keep your eyes on his follow-up video. I'm really in touch with him to make sure that we can finally replicate this. So after my last video, I went through every single comment you guys posted, and I read also a lot of comments that I'm testing on an open test bench, similar to what I'm using here. Usually that's what I do, because the open test bench, the ventilation is not that good. There is not really an airflow. So you're basically testing the worst case scenario again. But then you guys are right. This is not what you have in your gaming rig, right? So I took a lot of time and I built a system myself. I used the Fentex Evolve case, which is one of my favorite cases, which is also one of the most used cases at Caseking. And I built a full system in there. I used my motherboard, so I had the Asus X299A, I had the Asus Strix, the MSI Gaming Pro Carbon, and also the Gigabyte Aorus Gaming 3. And I put all those four boards after each other inside my system to test them all over again, do all the testing inside the system. So this is how the system looks like, and you can see I'm using one 140mm fan on the back, and I have two in the front pulling cold air in for some good ventilation. I have the H100 AIO on the top, and I'm using an EVGA 1080 Ti for the graphics card. And with this kind of configuration, I was testing everything again, and this time we were talking about the maximum power draw the boards could pull. So with the Asus X299A, with the Strix, and with the MSI Gaming Pro Carbon, the maximum I could pull in this configuration was 250 watt. And that's not the power I'm drawing from the socket, that's the real VRM power. So with this kind of power draw, you can run 4.5 gigahertz stable, but that's really the edge. If I clocked up to 4.6, it would eventually throttle, because that's the region when I hit around 270 watts, so that was too much over the long run. So for the Asus boards and the MSI boards, they had a VRM temperature limit of 105 degrees, and once it hit this limit, it would throttle down. And the Gigabyte board could pull a little bit more. It could pull 290 watt, which is quite a lot more. So I could run actually 4.6 gigahertz stable, but a 4.7 would eventually throttle then. The thing is that the Gigabyte board is using 115 degrees Celsius as a limit. So whenever I was hitting 115 degrees Celsius, it would throttle down. So it's a little bit better because they're actually using a higher temperature limit. I'm not really sure where they're reading the temperature from though. So it could be that it's not exactly in the middle. It could be in the outer areas. I'm not really sure about that. I want to make that clear. But the reason that I could run higher on the Gigabyte board was mainly because of the higher temperature limit. So yeah, I hope in this video you got a little bit more information about how I'm testing, why I'm testing the way I am testing. And I hope that if you're a reviewer with this kind of information, you can hopefully reproduce these results, and maybe we can dig even deeper into it, find more things out. Especially this AVX512 throttling thing is still on my mind. I'm really trying to figure out why this is throttling the way it is. I almost forgot. So when I was testing the motherboards again in the rig, I noticed that, of course, the H100 is very close to the VRM cooler, and it could be that the airflow is really not good to the VRM cooler. So I also tried to pull the whole H100 out, and I put it in front of the case. So actually the fans were blowing quite heavily onto the VRM, and the temperature did not really change. It dropped by like 3, 4, maximum 5 degrees Celsius, but not really a lot. So it's still an issue that just the surface is not enough on the VRM cooler. That's something I wanted to make clear before I have a lot of comments again on that my system build was just not good enough. So there's one more thing I would quickly like to talk about. So I have the Maximus 8 Extreme next to me. That's a Z170 board, and pretty much my favorite Z170 board. And let's take a look at this. So this board was designed for CPUs with the maximum TDP of 91 watt, aka 6700K. So let's look at the VRM design and look at the especially the heat sinks. So 91 TDP, and let's say with overclock we're running like 150, 160 watt, maybe 170. But then this is just what we have with Skylake X on stock. So look at this heatsink. The heatsink is massive. We have a lot of surface area, probably like 3, 4, 5 times more than what we have on, for example, the X299 Strix or MSI or Gigabyte. Doesn't matter which vendor. This has this was designed for a TDP that was much lower, but the surface area is so much higher, and the temperatures on this were really, really good. So what I'm trying to go on is that the VRM components itself on the new X299 boards are actually quite decent. So Asus, MSI, Gigabyte, they all use quite good, pretty much the best components you can get. So we have international rectifier components, but then the heatsink is just the issue. So the heatsink is very bad. The heatsink has no surface area, and also the thermal pads are usually pretty bad. I will do a follow-up video soon once I get the new heatsink for my Apex motherboard, and also I will do some testing what we can do against the issues, or what happens, for example, if we replace the thermal pad on one of the boards I tested and see how the temperature drops. I know that it drops, I can assure you that. So the question is only how high will it drop. So the thing I would like to point out is that if you're a vendor, and for sure I know that the vendors are watching this video again, just go back to some proper heatsinks design that are working well, that we have more headrooms, because I know that all the consumers, we really like to have our components cold. Like we don't want that the components are running at 100 degrees if we're overclocking, even though we know that 105 would be the limit. We don't want it to be at 100, because we know the higher we go in temperature, the lower the lifespan is. So what we want to have is combined design, but still make a very good heatsink. And I'm sure that you can even turn this into your marketing and make some new cool USPs out of having a very nice heatsink. So yeah, I really hope that we will see some very, very good heatsink designs as well in the future, and not only design-based stuff. So that's it for this video. I hope I gave you quite some more info about this whole topic and cleared up a lot of your questions you had. If you still have questions, put them all in the comments. You can be sure that I'm reading every single comment you guys are putting in. If there are still a lot of open comments, still things that are not clear, I will post another update video if necessary until everything is cleared. And yeah, I hope that you enjoyed this video again, and hope to see you soon.